Okay, so good morning, welcome and hello to another Beckhoff webinar. My name is Jürgenhake and I'm product manager in the IO department. And today for the next round about 30 minutes, I want to give you an overview about our power supplies. And with the slogan compact, powerful and reliable, the Beckhoff power supplies. As you know, perhaps from other webinars in the past, if you have some questions, then please use the question window. And then I can see if I want to ask these, if I want to give answers to these questions finally after this session, or perhaps individually direct by email. Okay, so these are the new product family of the Beckhoff power supplies. And perhaps you ask yourself, okay, why we start with power supplies? And you know Beckhoff as a system supplier for automation products. And in addition to IPCs or IO products, and as well to motion and the special automation software, we have this in a complete system. And now we expand this system by another relevant product, and that's the power supplies. And so we are talking about the standard DIN rail power supplies. And I want to give you now an overview about the portfolio, about the features, and as well about some special topics and the USPs, something like that. The complete portfolio you can divide into 3 different series. And I want to explain the 3 different series to you by some different application to make it a little bit easier. For example, if you have a small application, you need a little bit system voltage. Perhaps you have a small distribution box in the field, and inside this small box, you want to have only a little bit system voltage. You don't have so big loads. You don't have a very dynamic load current, so you have a stable current, for example. And the 100% output power is enough for your application. And in these cases, the products from the series PS1000 could be the right ones. And sometimes perhaps you have some very cost-driven projects, then the 1000 products could be the right one. So let me say, I named them the products for some smaller applications. If you have some bigger application, you have, for example, the demand on system and load voltage. You have standard loads, little medium current loads, for example. And if you have, for example, in the complete application, the demand to the power supply that it wants to give out more than 100% of the output power, then you can use the PS2000 products. So let me say, perhaps this is a series for the standard applications, for the most common applications. And if you have some bigger applications, some demanding applications where you have bigger loads, where you have very dynamic load currents, and where you have in total sometimes a bigger demand to the power supply than 100 or 120% to the output power, then you can use the PS3000 series because they are able to give an output power of 150%. So let me say the cluster of the complete portfolio you can divide in small, standard or medium, and demanding or bigger applications. But now we want to have a detailed look into the 3 series. If we start with the series PS1000, there you will find one-phase products for 24 volt DC. The output current starts in the lower range. So for example, the 60 and 90 watt product has got 2.5 and 3.8 amps. And then it goes via 5 and 10 amp up to 20 amp. The efficiency is very fine over the whole family, and it goes up to more than 95%. The output function is working with the so-called UI curve and with hiccup. UI curve is the wording of the behavior. So that means you have a stable output voltage for the whole nominal output current. And if the output current is going higher and higher, because, for example, of an overload or a short circuit situation, then the voltage drops down because the power is limited from the power supplies. That's the so-called UI curve. The hiccup mode is, let me say, on-off mode. So, for example, you have a short circuit at the output. That means that the voltage drops down. And if the voltage drops down under a certain level, then this kind of hiccup mode will start. And this mode exists as long as you have this kind of short circuit or the failure behavior. That means then in the hiccup mode, the output of the power supplies goes to the maximum for a special time. For example, in this picture, up to 5 seconds the first time. And then the power supply sees, okay, now we have the whole time this problem. Now I want to switch off. So then I can save the complete installation, the wiring, the product, and the power supply itself. And then after a certain time, in this picture, after 7 seconds, then I will start once again, and I want to have a look if the problem is still there or not. If the problem is there, then I can remember it by the high current and the low voltage. And then I switch off once again. And this on-off behavior is the so-called hiccup mode. And if the problem is over, so that means the high current demand is away, that means that the voltage goes up to the nominal level, and then the power supply stays in the on situation once again. At the input side, we have an active inrush current limitation. That's fine, because when you want to start the power supplies, you don't want to have very high inrush current, so that, for example, some fuses will break or the complete system is under stress. Then we have a wide range input of 90 to more than 260 volt AC at the input side. And the output voltage is monitored via a DC OK LED. And the bigger products in this series as well have a relay contact. And all together in a very compact housing. So that's the PS1000 series. If we have a look to the PS2000 series, then we have 1 and 3-phase products for 24 and 48 volt. The output current is in the middle range, 5, 10, and 20 amp, and the efficiency is very fine, and it goes up to more than 96%. And here we have now the 120% of the output power permanently over the whole time. And so that means if you have some different kind of loads and together they have more than 100%, then you can use perfectly these kind of products. So that means you will buy a 10 amp power supply and you will get a 12 amp power supply. Another feature at the output side is the so-called fuse tripping. So that means if you're running at the output side with a thermal magnetic breaker or an MCB so-called, then the power supply is able to give a short peak current out. This peak current is much more higher than the nominal current, and it is in the time range of many milliseconds, and that's enough to trip these MCBs. The UI curve is as well at the output, but here we call it the UI curve with reserve, because now we have the 120%. And as well, the hiccup mode is inside. At the input side, we have an active inrush current limitation. The PS1000 products are running with an NTC, and the PS2000 are running with an NTC and in parallel with a relay. So it's another modus for a good and low inrush current. As well, we have a wide range input. Here it starts at 85% and it goes up to more than 260 volts. 85 volts, and it goes up to more than 260 volts. The output voltage is monitored as well via the DC OK LED, and most of the products have as well a relay contact. As well, all the products are in a very compact housing. For example, the 20 amp product is only in 48 millimeters small. The PS3000 series, there we have 1 and 3 phases and 24 and 48 volt products as well. Here we have now the higher current. It starts at 10 and it goes via 20 up to 40 amps. and the efficiency is as well very high, and it goes up to more than 95%. The PS3000 series has got now a bigger output power. It goes up to 150% for 4 seconds. And as well, the same function regarding the fuse tripping for the secondary side of thermal magnetic breakers. As well, we have the UI curve at the output, as well with the so-called reserve and hiccup mode. Here we have the hiccup mode for the one-phase products, because this is a kind of protection feature, because you don't want to have the whole time the high current at the output, because you want to protect the installation, the wiring, the power supply itself. But you could have some special application. For example, if you want to start a load which has got a very high capacitive inside, then you want to charge the capacitors, and the current for charging the capacitors is nearly the same like in short circuit current. And then you want to have the high current over the whole time, and it's not so important when the voltage drops down. And for this application, you can use the 3-phase product because they don't have the hiccup mode. So you see special applications, then you can use the special products. As well, we have an active inrush current limitation, and in the PS3000 series, it's done by an electronic circuit, so very efficient. As well, we have the wide range input, and as well a DC-OK LED, and as well an overload LED in this series, and of course the relay contact. The 960 watt devices have as well as shutdown contact, so that means you can switch the power supplies via remote. And altogether, they are in a really compact housing. So you see for really different applications, you have 3 different series, and most of the applications are running with 24 volt DC, but there are as well some other loads in the applications where it is not enough to use them with 24 volts, so you need 48 volt. And therefore, I want to point out once again that we have 48 volt power supplies, and you need it, and they are needable, and you need them, because if you look, for example, in our own Beckhoff portfolio, you see, for example, the compact motion products, the I/O terminals, and the motors, you need 48 volt. The XTS system needs 48 volts. And of course, there are a lot other loads which are running with 48 volt. And therefore, we have 4 different devices with 48 volt, 1 and 3 phases, and 480 watt and 960 watt. And for example, the 960 watt products are belonging to the PS3000 series. So that means because of the 150%, they are able to give out more than 1,400 watt for 4 seconds. So that's perfect for motion application. If you have a look in total to the portfolio, you see the different performance by the 3 different series, 1,000, 2,000, and 3,000, and the big range of output current, starting at the low level of 2.5 amp, and it goes up to the high level of 40 amp. And then you see a good mixture of 1-phase and 3-phase products, 24 volt and 48 volt devices. So it's a very good mixture, so you can run all the application from our point of view by these products. Then this complete portfolio has got the wide range input, therefore you can use them worldwide. And furthermore, to use them in different applications, we have different kind of approvals and certifications. So for a worldwide use, the UL approval is a must, and therefore all our Beckhoff power supplies has got the UL approval. But furthermore, for some specific industries, we have some specific approvals. For example, for the process industry, we have the ATEX, ISCX, and Class 1 Div 2 approval. Or for the shipbuilding industry, the DNV GL, or for the semiconductor industry, the SEMI F47, for example. And if you have some special small circuits with lower than 100 watt. Then we have as well products with a so-called NEC class 2 approval. So you see in total a big portfolio with different kind of features, and it's very flexible because of the use and the good mixture. And you see perfect for a worldwide use, including special industries. But now we come to the most important question, I think, from your side is, okay, and what is so unique to the Beckhoff power supplies? And what are my benefits by using these kind of power supplies? This I want to explain to you with some technical background. Therefore, I want to give you some examples, one from the input side, one from the output side of a power supply, and a general topic to power supplies. And then I think it's easy to understand why they are so unique. But let us start with the input side. So if you have a power supply, you want to have a robust power supply against transients from the input side. So that means in the power supplies, there is an over voltage protection inside, which protects the own device against transients and high voltages. Typically, this is tested by the standard EMC tests, and you can make this by different kind of components. For example, you can use metal oxide varistors, the MOV, that's the blue one at the top, or you can use the gas discharge tube, the so-called GDTs. You can see at the bottom. And the differences are the following. If you have a look to the picture to the right, there you see a GDT. So inside there is a gas. Then you have the electrons left and right side, and then it's capsuled by some glass or some ceramic, for example. And this gas must be inside. And so the behavior of these GDTs is not so stable during shock and vibration or different kind of temperatures. So it's not so stable and durable like the MOVs, for example. And therefore, all the Beckhoff power supplies are using varistors only inside. That's also a good quality topic. Another topic for these inside, for the input transients, is a standard impulse test. So it's a surge impulse like the IEC 61304 and 5. All electrical components must fulfill this kind of test. So as well our power supplies. And this surge impulse is, for example, the so-called 1.2-50. That means the length of the impulse is in the range of microseconds, and the voltage is in the level of 2.5 or up to 4 kilovolts. So this is the standard, and all the power supplies are fulfilling this kind of test. That's fine, but there is another test which the Beckhoff power supplies fulfills. And that's the VDE 0160 pulse. And this pulse is a little bit special. So the difference to the surge impulse is, on the one hand side, the voltage level is a little bit lower. It's 2.3 times the peak voltage of the nominal voltage. But the length of this impulse is in the millisecond range. So it's much more longer. And therefore, the complete impulse is much more stronger and more powerful than the surge impulse. And so, during this impulse, all the Beckhoff power supplies are stable at the output side and, of course, are fine in the input circuit. So that means all the Beckhoff power supplies additionally pass this kind of test. And not all the power supplies in the market are doing this kind of test. And so it's another kind of quality topic to the Beckhoff power supplies regarding the robustness of the power supply. So they are really powerful and strong, and they they fulfill all these kind of topics regarding transients and impulses to the input side. The next topic is as well with an over voltage topic, but now from the output side. For example, you are running a small motion application, then you have, for example, a motor, and if you are stopping the motor during the braking time, it works like a generator. That means there is a current which goes back to the power supply, and therefore you have at the output of the power supply a higher voltage than the nominal voltage. And then you see an oscilloscope picture from some products from the market. There you have the higher voltage, for example, the 35 volts, and then it stops. So that means the power supply switches off. And then after that, it starts and goes back to the nominal voltage level of 24 volt DC. And you see here by the oscilloscope picture, there's a 100 millisecond one chapter. And you see that means roughly round about 200 milliseconds, the power supply is off. And that's really a bad situation because the power supplies must be on and stable during these kind of events. And if you have a look to this picture, because that's the Beckhoff power supply, you see that there is not a switching off time. You see behavior where the power supply goes from the higher voltage very smoothly back to the nominal voltage. And if you have a look to the time, here we are in the range of 4 milliseconds in the range. So that means here we are much more faster on the one hand side to go back to the nominal voltage, and definitely not by switching off the power supplies. And that means the Beckhoff power supplies are very robust against backfeeding loads. And so they are really perfect for motion applications. That's very important. And the third topic was the general topic. Therefore, I want to give you some basics regarding electrolyte capacitors. Because if we talk about the lifetime of a power supply, we must understand the behavior and the lifetime of the electrolyte capacitors. Because these capacitors drastically reduce the lifetime if the temperature is going higher. For example, by 10 degrees temperature increase, the lifetime of the capacitors is only half. And that's really a big, big value. And therefore, it's very important to have the complete topic of temperature in a good level. Then we can have a look now to explain the complete behavior and lifetime of the capacitors. We can have a look to the so-called bath tube curve. Here you see the lifetime of the capacitors. That means if you start running with kind of capacitors, there is there are some early defects with a very high failure rate. So that means if you are using these kind of capacitors inside the power supply, you could have very high failure rates because of the early defects of these standard components. And that's something what you don't want to have by the power supplies, because you want to have a high lifetime of the complete power supply. And to kick these capacitors out with the early defects, there is a so-called burn-in test in accordance to the IEC 60749-23. This is a kind of, let me say, stress test. So you start the power supply the first time, and then you bring the power supply under stress because of high currents and temperatures. And then you can check, or you will find these early defects, and then you can kick them out. Another topic, what is important to know is, if you have a look to the specification or to the data sheets of the capacitors regarding lifetime, then the suppliers are maximum giving, or the maximum lifetime of these capacitors is 15 years. That's not more. So that means if you want to compare, for example, some power supplies, and you find values higher than 50 years for the complete power supply, then it is a theoretical calculated value. That means if you want to compare a power supply 17 years with a power supply 20 years, then they are, let me say, on the same level, because the maximum is 15 years. And so now, because of this know-how, we want to go to the complete power supply topic, and so to the question, how do we get a high lifetime expectancy by the complete power supply? And therefore, the design is very important, because we must have a cool design. So we must have a very good convection cooling for the complete power supply, because then we are able to cool down the components inside, and so that the lifetime of the components are good, and then the complete lifetime of the power supply is good. And so then you must know the incoming air into the power supply is at the bottom cooler than at the top. That's clear. And so you can find a good position of some really important components. For example, in the picture, you see at the left side at the bottom a bigger brown circle. That's an electrolyte capacitor. So that's perfectly positioned at the bottom, and you see a lot of air lines are going around the capacitor, so it is perfect cooled. But of course, it's not possible to put all the components at the bottom, because the power supply has got an input circuit, an output circuit, and therefore you see at the top to the right 3 brown circuits again, that as well capacitors, and there you see a lot of air lines left side and right side nearby these kind of components. So they are as well very good cooled. So it's important to have not too much components inside, because you need a little bit free space inside a power supply because of the good cooling features and a very intelligent position of the components. And then you are able to have less losses and a good behavior of the temperature. And last but not least, then as well, you must do the 100 burn-in test in according to the standard. So that means every single power supply at Beckhoff fulfills this kind of burn-in test, and it was done by the standard. That's also very important. Sometimes some are doing some burn-in test, let me say, very fast and not in according to the standards. So that's very important, and that's the big benefit to get a high lifetime. You need a good design, then you have really good quality levels. And so I want to come to the big unique selling points for each device that we have. Because of the good design, we have really less losses. Therefore, we have a really high efficiency. And because of that, we have a high reliability and a long lifetime. It's all together because the story behind is the temperature and the less losses, and then we have really a good and long lifetime. And the product is really very robust against external influences. External influences, for example, the input transients or the backfeeding loads, the output voltage at the output side, or the temperature topic in total. The products, because of the good cooling design, are therefore as well very stable against the temperature inside the complete cabinet, which comes from the other components and goes to the power supply. So then the power supply is as well very robust against the temperature which comes from outside to the power supply. And all together in a very compact housing. So that means it's really a quality topic of these topics, long lifetime, and yes, let me say, robustness of the complete family. And it is not important if you buy the smallest power supply of, for example, 2.5 amp, or the biggest one with 40 amp. All the Beckhoff power supplies fulfill these kind of, let me say, basic characteristics. So that's our standard. All power supplies have got this high lifetime, high efficiency, and so on. The differences regarding the products and the 3 different series are then the features. Let me say, like if you want to have a shutdown contact, if you need an overload LED, or if you need the precise fuse breaking at the output or not. That's then the differences regarding the features. But the basic characteristics of the quality topics are in every power supply. And that's the unique topics of the power supplies. And then last but not least, we can have a look to the special USPs and to your customer benefits. So the products have got very high efficiency and less losses. And so you can reduce your system costs because of energy and cooling. We have a long lifetime, and so you can reduce your service costs. So that means you can put the power supply into your machine, switch the machine on, and then you can, yes, and then you don't have to think once again about the power supply because it's running and running. The power supplies have a very high reliability, and therefore you have a higher system availability. We have a compact housing, so you can reduce space and costs. The products are very robust against the temperature, so once again you can reduce the energy costs for cooling, for example. They are robust against the input transients, so you have a safe operation and a higher system availability, and the same to the backfeeding loads because of the robustness of that. And we have an active harmonics correction at the input side, so the so-called PFC. So that means you have less system faults and less follow-up costs. Then we have the active inrush current limitation, so you have a higher system availability and lower power grid stress in total. And last but not least, we have an overvoltage protection at the output. That means if a fault is inside the power supply, then you don't want to have a higher voltage at the output so that your loads will be damaged, for example. We have a special electronic circuit inside, then we can we monitor this situation, and if there is a fault, then we switch off the power supply, and therefore your loads are protected. And so the benefit is, by this feature, you can reduce possible follow-up costs by some damaged loads. So this in total makes these power supplies very unique, and they are very powerful. And yes, so from my point of view, you see there is a big portfolio for different kind of applications, for different industries, for a worldwide use, and with very special technical features inside to have them on a very high quality level because of robustness, lifetime, less losses, and something like that. That's it from my side. And then last but not least, if you have some questions, you could use this question window, but I have a look. There is no question up to now. So if you will have questions in the next days, feel free to contact your Beckhoff contact person, and then I will answer your questions by mail. And this webinar is recorded, so you will find it in our web page on the archive. Then you can have a look once again to this webinar. And if you have, for example, some ideas for possible webinars, then please let us know so that we can think about to make special to your wishes some webinars. Okay, so that's it from my side. Thank you very much for your time, and see you the next time. Bye-bye.